Until now, we have seen basics of databases. Then we have seen DML, data manipulation language, some of the commands, important commands in that, where condition, order condition. And then we have discussed DDL language, some of the commands in creating the table, creating a foreign key, creating a primary key, etc., etc. We have executed until this place. In fact, we have created a couple of databases, and we have a table. Let's say if you go to customers table, you have some indices, primary keys. If you go to that orders table, then you have the primary key as well as the foreign key. We have seen all those concepts until now. Now let us learn some more important commands within DML language, data manipulation language. This is DML again, level 2. Not always you may require all these commands, but it's good to know them so that you can reach from basic level to intermediate level to advanced level when you are exploring more and more of these commands. First, let us get into how do you insert a new data point into an existing table. You can use this command called insert into, write the table name and mention the values. For example, if I go to our database, right now we are working with sales database, sales one database. What if we want to work with sales database? Let me create a new SQL file itself. Anyway, these code files are already with you. Only use them as your reference. Don't copy paste the code from there. You have to write like the way that I'm writing the code here. So let us use the database sales. Okay. So let me first increase the size. Use sales database. As soon as you do this, when you execute this, sales will be highlighted. Within sales, if you look at the table payments, payments table has these four numbers. What if I want to enter a new row into that? So you write insert into is the command. Insert into, what is the table name? Payments. Insert into payments. And what are the values? What are the values? You write values. And then you write whatever the values. Remember, you have to give in this order. Customer number, mention the customer number. Customer number is numeric value 690. Next one is check number. You have to give the check number. Check number follows a particular order 112233. Some varchar. Okay. Then the next one is payment date. Now this we need to be giving that carefully. So to be on the safe side, what we will do is let us look at some of the example values from the payments. Select star from payments. That will give you an idea when you're entering so that you can enter in that particular manner. Okay. Then you give the, looks like this is date time. I'm sure date should be acceptable. 2006 followed by month followed by date. That is the format that we are supposed to give. Followed by comma, comma. Next one, last one is amount, whatever is the amount that I'm giving is 3000. 3000 is the amount that I'm giving. If I execute like this, then it will insert a new value now. Okay, this is inserted. How do you check that particular row? Select star from payments, where if you want to print the same row that you have entered, where, what is it, customer number or amount. I'm assuming that there is no other amount that is exactly 300, 3000. Let us say amount equal to 3000. Okay. First, let me close that command and then let's execute this command. 690 ABB1132, exactly whatever we have entered. That's how you enter a new data point. Or you can use another command called update table. So you write update payments table, and then you can set one by one column. Okay, update payments table, set customer number as whatever is the customer number. Let me say 800. Okay, then check number as a particular value, AA 1413445. Okay, that is a check number. Okay, if you want to update a particular value, let's say here customer number is 690. For him you want to update this value, because for doing the update, that means you have to update a particular value. Okay, so you set customer number as any number. Okay, our customer number is the one that we have to compare, so let us not give the customer number. Let's update the check number. Check number, we wrote it wrongly. AB112233 was the check number, but we want to set the check number like this. Okay, if that is the case, where customer number is 690, customer number is equal to 690. What are we trying to do here? For the same customer 690, by mistake we gave the wrong date, AA, or we gave the wrong check number, AA112233. So what we are doing is update payment set check number equal to this one instead of this one, where customer number is 690. If I execute that now, it is executed. Now, if I print the same one, the updated values are printed. If you want to update the existing table, if you want to change that, then you can use this. Okay. It is used for modifying the existing records. This is one way. Or if you want to add new records, if you want to insert data, then you can use it. You can use the above command. Okay. Now there is one more command called is null or not null. Okay. For example, if I want to print some data from, let's say, let us take one table. Let us see one of the table here. Let us suppose orders table. In that, what are the columns? Yeah, these are all the columns. From the orders table, select star from orders table. Okay, from orders. Select star from orders. If I execute this, oops, select star from orders. Here you go. Comments are null. Null means not available. The data is blank, null, nothing is there. What if I want to subset? I'm interested in only those places where the data is null. So select star from orders where your column comments is null. What is the command? Is null. That is a keyword. The keywords are highlighted here. So instead of printing everything, if I want to print only those places where comments is null, this is what you will use. What if you want to do the opposite? What if you want to print only those orders where the comment is not null? Everything where comments are actually available, that is what you want to print. Then you say where comments is not null, is not null. That means you will get everything where comments are available. Is null will print everything that is comments available. Is not null will print this one. In fact, you can give like ship date is also null here. So let me put two constraints, two conditions, where conditions. I want to print everything where comments is not null, as well as shipped date. Shipped date is also not null, is not null. So ship date should be printed without null, as well as comment should also be without null. Okay. So I have to put an and in between. First comment, first one is where comments is not null and ship date is not null. Both the conditions must be satisfied. Then only I want to fetch that data. Now ship date will also have not null values. Comments is also not null. While you're printing, you can limit the data that you want to print. Let us suppose if you're printing payments, let's say if that is a huge data set, let's say if you're printing orders, imagine that's a huge data set, but you're not interested in printing it completely. You want to limit the number of items that you want to print because you just want to have a look at the data. You want to see a sample data only. Then in that case, you can use this command called limit. If you use limit 3, or let's say if I say limit 5, only 5 rows will be printed. Check that out. 1, 2, 3, 4, 5. Let's say limit 3. First 3 rows will be printed. That's it. 1, 2, 3. This default null, null, null is printing. That's not part of the data. Look at this 3. Limit. It limits the number of records that are being printed in the output. Okay. The next one is called wild character, or it is known as regular expression. You can use like operator. This is a very interesting one, like operator. For example, if you're writing this command, select star from, let's say if I go to employees data, in the columns, let us print the employees data, select star from employees, select star from employees. In these employees data, in this data set, let us suppose I'm interested in, whenever it says VP sales, VP marketing, vice president, I want to get all the data of vice presidents, but I don't know. Sometimes it is VP sales, sometimes it is marketing VP. So it will be very difficult for me to know all the patterns. Okay. So what I need to do is wherever it says VP, I want to get that. Okay. So there is an option for that. Okay. Like if it starts with VP, if job title, it starts with VP, vice president. Now, whatever it is, vice president of sales, vice president of marketing, vice president of operation, I don't care. If that string starts with VP, then I want to take that. Okay. Then you can use this operator called like operator. Okay. So here is the syntax. Select star from employees where job title, job title, job title. Then you have to use like operator, job title, like VP. Now, if you write simply VP, now job title like VP means it will look for only VP, but VP followed by anything. To mention that, you have to use a percentage symbol. What does this mean? this particular VP letters followed by anything that is perfectly fine. It is sales or marketing or spaces, it doesn't matter. If it is simply contains this, it starts with this, not contains. If it starts with this, then we'll be able to find that out. Okay. So if I execute this, these two are printed. If I want to do the opposite of it, let us suppose if I look at the select star from employees, let's say anything that ends with rep, sales rep, customer rep, anything that ends with rep, it should end with rep. Previously, it was starting with VP. Now I want to end with rep. Anything can be followed by, it has to be ending with rep. In front of it, it can be anything. Here it was starting with VP. After that, it can be anything. But here ending should be rep. Starting can be anything. How do I achieve that? Anything means you would just simply percentage symbol. Then if you execute this, in the beginning, it can be anything. At the end, it has to be rep. Then it will take. Okay. That's the one. Have you got it, everyone? Now, there are some other wild characters. These are known as regular expressions. There are some other regular expressions as well. For example, if you want to find out in this one in extension, if it contains anywhere 2 in the extension, I would like to consider that. If it contains 2 in the extension, it doesn't matter where exactly 2 is. So what I will say is employees where extension like it should contain 2. Before 2, it can be anything. Before 2, it can be anything. After 2, it can be anything. Basically, it should contain 2. That's it. That's what I'm worried about. If it contains 2, before it, whatever it is there, after it, whatever is there, I don't care. If that is the case, if I execute that, 9, 2, 5, 4, 2, 3, 2, 2, 1, 2, 2, everywhere, 2, 2, 2, 2, 2 is there. Getting it? This percentage means anything, then this one, anything. But what if I'm looking for specifically 2 in the second character only? Right after X, 2 must come. 2 must be there in the second character only. Then percentage means anything. But 2 must be there in the second character only. Then the symbol is different. In regular expressions, if you want to have a particular number, right after that 2 should come. After that, anything can be there. If that is the case, you have to give underscore. What this will make sure that is anything followed by 2, just one particular item or one particular character followed by 2. After that, it can be anything. If you execute this, check this, only 2 is appearing in the second place. What if you want to have 2 in the third place? Then you write it like this. Then any number that is where it has 2 in the third place, only that will be printed. These are known as regular expressions. It's good to know some of these regular expressions. That itself is regular expression itself is a very big topic. But as of now, you can look at these examples, some of the regular expressions where if you want to have anything in the beginning, then you give percentage in the beginning. If you want to have anything afterwards, you can give this one. Let us do one more example. Let us take select star from orders. Let us take some more examples to get a better understanding. I think select star from employees. Let us go for employees. Okay. Select star from employees. No. Let's take some other data set. Payments data. Let us take select star from payments. Payments. Suppose that my requirement is the check number. You want to get all those check numbers where the second character is M. That indicates that a particular branch. Okay, M is indicating the second character is indicating M. So before M, there has to be exactly one character. After M, there can be any number of characters. So how do I get to know that? How do I select only that data? These are not, we are not doing these for fun. Sometimes these are your requirements. You want to select all those checks from a particular branch, and that branch is identified by looking at the second character. If it is M, that means that is a branch code, and we want to get only those checks. We want to clear them now. So I'll write down select star from payments where check number is like check number like a particular pattern. What is the pattern? Check number like, what is the pattern? The pattern is anything. That means any one character followed by M. After that, it can be anything. So one particular character, if I write like this, I may not get the right answer. If I write like this, I'll get M anywhere. Okay. M in the beginning also it's coming. No, I'm not interested in that. I want to have exactly M right after first character. That's what indicates my code. Look at this. M is in the second character. Okay. That's the example that I'm talking about. Like operator. Okay. Yeah. You can also give, like, you can do a lot of experimentation with this like operator. Okay. Or if you want to have this where the check number is starting with N, ending with 4. If you want to have such thing, the check number always should start with n, and it can have anything, but it should end with 4. N, anything, 4. If you give like that, then you will get all those checks where they are starting with n, ending with 4, starting with n, ending with 4. You can get these specific details when you are using these regular expressions like this. Okay. You can explore more and more regular expressions later on, but as of now, this is just a basic introduction to this like operator. There is one more operator called between operator. You can get all the data between two values of a particular column where the age is between 30 to 60, okay, or a particular date is between this date to this date. You can use between operator for it. Okay, so you write select star from payments data only, where the amount has to be somewhere between 1000 to 5000, where amount is between 1000. You cannot say two, you have to say and 5000. That is the syntax. Select star from payments where amount between 1000 and 5000. So if you see the amount is exactly 1000 and 5000. If you want to make it simple, let us make the amount 1000 to 2000. Everything more than 1000, less than 2000. Okay. You can also apply these on the dates. Okay. Select star from payments where the date, which date is that? Payment date. Payment date is between which date? You have to give in the same format, by the way. So let's say 2004 01 from this day. I want to take that financial year 2004 01 to 01 to 04 01, from this date to 2005 03, let's say 30 or 31. Let's say, let me say 30 only until this date. Okay. If I want to select the data 2005, by the way, 2005. If I want to select only data between these two, then everything between 2004 that time to 2005. Nothing beyond that. Okay. Everything is in between. There is one 2005, but 02 only. Or if you want to make it simple, 2004 to 01 to, you can say 2004 05 01 or 430. Only April month in 2004 you're interested in that. This is completely April month in 2004 data. Between operator. Let me give you another requirement. My requirement is I want to select all the countries where the credit limit is more than 80,000. Average credit limit is more than 80,000. First of all, let us calculate average credit limit. So the credit limit is in customers data. So go to customers data in the columns. First, let us do select star from customers. Select star from customers. Several columns are there. One of the column is credit limit. You see that credit limit? Now what I want to do is, and there is one customer country is also there. Customers from different countries are available. What I want to do is I want to find out what is the average credit limit by country. For within every country, what is the average credit limit? So how do you do that? Select average credit limit. Select average credit limit from customers table, customers. And by country, you want to have credit limit. So group by country, group by country. So if you do this, if you execute this, these are the average credit limits for every country, but where is the country name? So you have to select country as well. So when you're doing this aggregation, always it's a good idea to select group by also inside that, so that you can see France has higher credit limit, USA, Australia, Norway, Poland. These are all the credit limits and countries. What if in this table, I want to select only those countries where credit limit is more than 80,000? Only I want to take only those countries where the credit limit is more than 80,000. So what I'll do is I'll write this whole command and I'll simply say where, let's say average credit limit. Okay. Where average credit limit is greater than 80,000. That is the command that I'm giving. And then if I execute this, it is throwing an error. What is the reason for this error? You cannot use where condition. You cannot use where condition after group by. This is not possible. It will throw an error. So there is an alternative to this. Where doesn't work here. So you have to use having average credit limit greater than 80,000. That will work. Greater than 80,000, greater than 80,000. Let me execute this. And again, greater than 80, greater than 80, greater than 80, everything. But if I write where here, does it work? Nope. Here itself it is throwing an error, showing some error. It is not working. So where doesn't work in the aggregation. Aggregation, it doesn't work where. So you have to use having. Having is used in aggregation. A better way would be you save this as average credit limit and then where average. Where means having Average credit limit greater than 80,000. What if I give an alias? Does it work there? Let us see. As average credit limit. If I give alias, does it work? Then if I write where average credit limit is greater than 80,000, does it work? No, it doesn't work even then. In aggregation, make a side note here. In aggregation, you must use, what do you must use? You must use having only instead of where, then it will work. Okay. Now, there is one more command called if exists. If the data exists, then only print it. Or if my condition is satisfied, then only print it. Okay. Let us suppose if I want to get the customer's details, however, if the customer number that is given here, if it is there in the payments table, there are so many customers, I'm not interested in all of them. If some of the customers, their customer numbers are matching with payments table customer number, if it exists, then only I want to print them. Then how do I do it? Select star from customers. Select star from customers exists, where exists. Then look at the command here. Select star from payments where customer number, customers you have already selected, customers dot customer number is equal to payments dot customer number. Customers dot customer number is equal to payments dot payment number. Then if you execute that, then for all those records, if this is true, where payments, from the payments, if the customer exists, then only in the payments data, if the customer exists, then only we would like to get those details from the customer. You can achieve this in a different manner also from the left outer join, or there are 2-3 ways of doing it. But where exists, what it does, it will check whether this particular customer number, if this condition is matching, then only you will get the details here. If that condition is not matching, then you will not get any of these details. That is what where exists. Not every time you see people using it. In future, if you want to have a condition, if this condition is satisfied, if this data is found in that table with a condition, then only I want to print this data here, then you can use this where exists operator. Then usually we have some if then else statements when you're working on Excel. If then else, even in some other tools also, you would like to see if then else commands, isn't it? If then else. Now that is here, it is known as case when. For example, if you go to this payments data, okay, let's print payments data. How does it look like? Select star from, I keep on missing this semicolon. Select star from payments. Select star from payments. Now I want to create a new column called amount band. If the amount is less than 5,000, I want to say amount is low. If it is 5,000 to 30,000, I'll say amount is medium. If it is more than 30,000, then I would say amount is high. Low, medium, high. Amount band is what I want to create. So what do we want to create? Amount band. So how do I create that? Here is the, and I want to do all this and store it in a new table. Otherwise, directly also you can do it. Select star from, or select star, and then from payments, that will come later on. Say from payments. But before getting there, I have to, apart from selecting star, I have to select some other one also. Case when. Case when amount. When amount is less than 5,000, then what? Then it has to be low. Amount band has to be low. Okay. Then when the amount is less than 30,000, that means 5,000 to 30,000. So you write it in the second line. Case when the amount is less than 5,000, then low. Okay. When the amount is 5,000 to 30,000. You don't need to write 5,000 to, because less than 5,000 means automatically more than 5,000. It will come to the second line. More than 5,000, less than 30,000, that is medium. But more than 5,000 not required to write, because already if that condition is satisfied, not satisfied, it will come here. These two conditions, else high. You simply write else. Otherwise, you can write a condition also, amount is greater than 30,000 and all that, else high. Then finally, you end this whole thing as and as amount underscore band. Look at this. What am I doing? This is little confusing in the first time, but overall it will be easy to understand. What are we trying to do here? First, select star, all the columns from payments table. That's fine. I'll select all the columns. Case, apart from all the columns, case when amount is less than 5,000, low. When amount is less than 30,000, medium. Else, high. And this result, low, medium, high as amount band. From which table? From payments table. Now, if I execute this, what is the output that I'm getting? Medium, medium, low, high, medium, low, high, medium, high. Check this out. Is this working correctly? Medium amount is less than 30,000. This is 6,000. This is 14,000. Less than 5,000. Medium, high, low, medium, high. Have you understood? Let us do one more example. Maybe let's go to customer data, any numerical column that we have. Let's go to employees data if we have any numerical columns. No. Let's go to orders data. Definitely we will have numerical columns. You will have order date, comments. Price is not there. Oops. So let's go to some other data. We will do one more example on this case when to understand it much better. Products. Products has MSRP. So we will do case when on MSRP. Products. So quantity is also there or MSRP is there. Simple case when I want to do when MSRP is less than 1,000 low and when MSRP is more than 1,000 high. That's what I want to do. So here is the code. Select star comma that case when and it will end as select star comma that whole case when I will write and you want to end that case when as end as MSRP band. Okay, MSRP band from which table? Products. Okay, that is the command. Now let us write case when MSRP is greater than 1,000 you want to say high. Okay, when MSRP greater than 1,000 then high. Okay, else low. Okay, and this whole thing as MSRP band. If you execute this, low, 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 all of them are low. Everything is less than 1,000 only. Okay, let's put that as 200. Looks like all the values are small, very, very small. Let's execute this. Now, now what? Low, 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 low. Everything is less than 200. Oops. Yep, high is there. Yeah. In fact, if you want to really see that, you can order by MSRP. Order by MSRP to have it easy to locate. Oops. Order by must come before from, isn't it? Order by MSRP. Is that going to work? No. In case when can't we select order by? Let us see. Order by. Am I missing anything on this? Anybody? Order class unknown column MSPP, MSRP. I think this is a mistake that I have done. Let us check. Yeah, a small syntax error. Now it is ordered by MSRP. Right at the end, you have too high, high. Imagine you have a table. Let's say you have customers table. And every month that customer table changes. Every month you get newer and newer data in that customer's table. And every month you're doing the same job. Your job is to find out how many records are there in the table and what is the average credit limit. If you go to that customers table, select star from customers. If you go to that customers table, there is a column called credit limit. Every month new data comes, you will be calculating average credit limit for that new data. Every month new data comes, you will be calculating the number of rows. So usually what is the code that you write? Every month you will be writing this code. What is the code? Select count star from customers. That's the first command that you will write. You will get this data and you will keep it somewhere. You will report it. These many customers have come. These many details are there this month. And then what is the other command that you will write? You will also calculate the average credit limit, right? Again, you write another code, right? Average credit limit, okay, from the customer's data. Average credit limit, okay. These are the two commands that you will be writing. What if every month you are doing the same job? What if you can write a function around it? Function means automatically it will execute. You don't need to write these two commands again and again. You can create something called stored procedure. Stored procedure is like a function in the general outside language. What is a function? It takes the input, it gives you the output. You don't need to write this whole code. You can create a stored procedure. And if you call that stored procedure, automatically you will get these commands executed. A stored procedure. What is a stored procedure? Stored procedure. A stored procedure is a pre-prepared SQL code. Okay. Set of commands, you put them inside a function, then automatically the stored procedure will actually give you the result if you just call that stored procedure. Okay. You can also pass the parameters to the stored procedure. Let us see an example of how to create a stored procedure. This involves a little bit of syntax. Let us see. Delimiter is ampersand ampersand. Delimiter is ampersand ampersand. And then create a stored procedure. Create procedure. Give a name, my procedure, or here I'm giving my name as basic stats. You can give any name here, and it has to be parenthesis. Okay. Create this procedure. Begin is also part of the syntax. Begin. Okay. Begin. And whatever commands that you have, write all of that. Once you say begin, you keep on writing. Okay. Delimiter. Okay. And then you write whatever you want to write. You want to every month, whatever job that you're doing, whatever SQL commands that you're writing, you write them, all of them. Okay. Then once you have written all of them, then after begin, you say and. After and, you have to put ampersand ampersand. Okay. And ampersand ampersand. Okay. Then you say again, this is part of the syntax. Okay. You say delimiter again. Delimiter. Okay. This time there will be no ampersand, simply close that. Now this is called a stored procedure that will be saved actually. If I execute this, the stored procedure worked. And if you go to stored procedures, if I refresh this in sales data, inside stored procedure, where is that? Let's refresh this. What's happening? Let us see. There must be a stored procedure here created. Let us see. The stored procedure, has it worked? Let us see whether it has worked perfectly or not. Created the stored procedure. I think previous command would not have worked. Let us refresh. Basic underscore stats stored procedure is created. Now next month, freshly the data comes. Don't worry about the data. Don't worry about writing the code. You simply write, call the stored procedure. What is a stored procedure? Basic stats is my stored procedure. If I call that simply, this one line of code, maybe 100 lines of code you have written in that stored procedure will automatically calculate whatever you are looking for. Average, credit, limit. It has also calculated the other one, but the way we wrote the stored procedure is returning this one only. Basically, if you have written, if you are storing somewhere else, if you are creating a table here, then it will print it. But here automatically the second one will be printed. Okay. That is called a stored procedure. A stored procedure will actually store all the commands. So once you begin, if you are writing multiple commands, you will get, let's say, select count star from payments table as well. I'm just checking whether if I give two tables, will it work? You are getting two different values from a stored procedure. I think first of all, whether this is going to accept the same stored procedure name or not. That's the first thing. It is throwing an error because we are giving the same stored procedure name. Let me call that as stored procedure basic stats one. Then if I execute this, it worked. So stored procedure created. If I execute this now, average credit limit and result 3 count is 122. Is that from payments table? Oh, I have to call basic stats one. Okay. Basic stats one. If I execute that, look at this result 4, that is count is 122, result 6, result 7. What is result 7? 274 from payments. Okay. Let me as cust underscore count. This is customers count. Okay. As average limit. Okay. As payment count. Pay count. Okay. Now if I create the stored procedure, basic stats 2 procedure, if I execute this now, what will happen? Stored procedure created. Let us execute basic stats 2. There you go. Result 8, customer count, average limit, payment count. Now, what if I take this whole code that is up and above me, whole code, everything, and then if I put that in the stored procedure, let us take a couple of them, okay, or maybe select ones only I will take. If I take these commands, these, all the select ones I'll take, because every month I have seen that I'll be doing all this job and I'm creating a huge stored procedure for all of them. So here is my stored procedure. It calculates these, begin calculating all these, begin and then end. Such a huge stored procedure that I have created. Now that stored procedure name is basic stats 3. So let me copy this and paste it at a new place, Control X, and then new SQL file. This is my stored procedure. This is my very lengthy stored procedure. If I execute this, stored procedure is created. Now, if I go here, the stored procedure name is basic stats 3. If I go here and select basic stats 3, if I execute this, all those commands are executed. 11, 12, 13, kept on executing. Check this out. So your full month work, completely what you need to do in that month, every month, if you are creating some reports where you have to execute multiple SQL commands, you can bundle all of them. You can keep inside a stored procedure. And once you execute that one line, every month you come here, simply execute this one line, that the data is refreshed. Anyway, you will get all the results. That is the effectiveness of the stored procedure. That completes our topic on DML part 2. DML part 2 is done. Now in the next session, we will go to DDL part 2. That will be our last topic on this SQL. Thank you, everyone.